I'm Dave. Welcome. We just realized that my laptop, for people online, my laptop, I forgot my charger. We're at 50% and we're hoping that it'll last. If it doesn't, then we're gonna have to swap laptops.
You've got a panel right there.
Yeah.
I know, we thought it's a little bit funny that the presentation about solar might lack power.
Have a seat right there. She's gonna drive
Oh,
the session.
yeah.
There you go.
It's good to clear. Again, here was our.
That's
Yes, to us, but
Yeah,
we may have some other people come from the library, it looks like.
yeah.
We love technology.
All right, so I'm from Solar Ypsi. Solar Ypsi is a loose group of friends that just help people do solar. In the back there is Nick from McKay. He's a local electrical supply company, so he's the person that actually sells the panels. And then we have Absolute Solar, who's a contractor who installs solar panels. And they're gonna put together a special program. The idea is that we can get a group get, I don't know, 5, 10 people to all do it at the same time, and they can get economics scale at a lower price. So they'll talk a few minutes at the end about what they want to do. But I also have other contractors. I have business cards on this table here, so feel free to grab a couple of those. There's a website called GLREN, Great Lakes Renewable Energy Association, and they have a list of solar contractors. So that's it. So the motivation here is to explain how it works, answer all your questions, and then hopefully you'll go and get some quotes, and then you'll go ahead and do it. Ask questions along the way. People online, ask questions in the chat box, and Mary will try and answer them, and if she can, we'll move along. She has solar on her house. Nick has solar. I have solar. So you can ask anybody who has solar about solar. So we're going to talk about solar power. Electricity is basically electrons that are moving through wires, and so you can't create electrons, but basically what you do is you energize them, and this stuff works.
Oh,
So it's weird. Oh no, it's lit. It's lit.
I'll advance for you.
Okay, advanced. Let's skip the history. So Solar Ypsi has been around for since 2005. I did my first installation at the co-op. Panels are about 40 inches wide, 70 inches tall. And when I did that one in 2005, that cost $1,000 and was 190 watts. Today, you can buy that same shape roughly, and you'll get 415 watts, and it costs about $200. So the price is just dropped from the floor. It's amazing. Keep going. And we brought in maybe $500,000, which I'm really proud of, in the city of Ypsi. My goal is to just get the most solar as possible in the city of Ypsi. And if you actually look at our per capita solar, we're like in the top 20 in the nation. We're a small town, so we got an advantage here. But so that's my motivation. I'm just trying to get as much solar installed as possible. And my other motivation is just it's a good economic thing to do. You know, there's all these environmental issues, and that's the easy stuff, but it's a good economic solution. And the way I look at it is, if you look at a map of Michigan and you draw a circle around it, forget the number, but it's tens of billions of dollars of money that leaves the state to go buy coal, oil, gas. And so if we could make our own energy, however we do it, then that's like injecting billions of dollars into the state economy. And so that's kind of my motivation. And you can scale that down to a city or to a house. And so lately I'm motivated to try and encourage solar on low-income houses, because a low-income house is a house. If we could put solar on that house, forget all the environmental effects. Basically, what you're doing is you're handing that household $50 a month for the next 30 years, because they're making their own power. They don't have to buy it from DTE. So that's kind of my motivation. We'll skip these steps. This is where all of our power comes from. These slides, well, an older version of these slides are on the Solar Ypsi website. I'm going to try and upload this fresher version later today.
Next one.
Yeah, next one. All right, so this is what we're going to, our talk is around a kind of this schematic. So this is what a system would look like. We're going to have some panels. This is Yeah, this is the co-op. And you can see how we grew it over a year. So we had some in 2005, some in 2007. But basically, you have panels on the roof. Panels look like this. They're bigger, but it's aluminum frame. It's tempered glass in front, so they're rated for 1-inch hail. You have some cells. The cells are wired in series and parallel, and you have a couple of wires coming off the back. Actually, they have these fancy connectors. So I have people all the time say, "Can I help you wire up some solar panels?" I'm like, "Sure, here you go." I mean, it's really that simple up on the roof. So you wire up your panels on the roof. It goes down to a disconnect. The disconnect is just a safety feature. So if your house is on fire, the fireman can turn off the power, or if you want to do some maintenance. The red box there is called an inverter. There's a couple different styles of inverters, but basically what that's doing is that's listening to the power from the utility company, figuring out what it looks like, amplitude, frequency, voltages, and all that stuff. And then it's going to take the DC power off your roof, convert it to AC, and then backfeed it into your breaker. This was kind of my aha moment, was this is how solar connects to your house. So if you have an electric stove in your house, you would put a 240 amp breaker in your breaker panel, and you'd have power going out from your electric stove. If I put solar on my house, I have my panels, I have my inverter, same kind of 240 volts breaker, and now the power is coming in through the breaker instead of out through the breaker. At the end of the day, it's just another breaker in your panel. And then you can do some metering and stuff like that. But yeah, thanks for doing this, Barry.
Yeah.
This is my duct tape son from 2005. And this is my solar panel from 2005. That direction is south. I'm going to turn it this way. Let's pretend that's south. And the sun is in the south, right? And it's low in the wintertime and it's high in the summertime. That's because the earth is spinning on an axis that's tipped. And it rises in the sun and it rises rises in the west. That's rises in the east. That's in the west. The point is that the sun is moving all over the place, right? So when you want to put your solar panels, and this is what the different paths of the sun would look like, over the course of the year. And what you want to avoid is a tree, right? So if you have a big tree that's sitting on your roof, so here's my house, right? And so you want, the ideal situation is for your panel, if I go to the next slide, is to have the panels facing due south, and the optimal angle is to have this tipped at your latitude, minus a couple degrees. So that if you have that is the perfect solar orientation. If your roof is a little bit different, and that's what we do, we just kind of put them parallel to the roof. That's okay. You only lose a couple percent. And if your roof is off due south by a couple degrees, that's not a big deal either. My house is actually, east and west. So here's south, my house. People online can see this. So right, so this is, you want south facing roof, that's the best. If you have an east and a west facing roof, it still works. You'll get a lot of power in the sun in the morning, but you'll get fewer in the afternoon. If you have this kind of orientation, this will make about 75% of the power as this. All right, so the same installation costs the same amount of money, but if it's facing south, you're going to make 100% of the power, and if it's facing this way, you're going to make about 75%. No, it just makes your return on investment a little bit less. And you want to tip it at your latitude, and you tip it down a little bit. We're at 42. I've been putting things at 38 if I can, and that's because we get more sun in the summertime, so you want to kind of tune it for the sun. Next slide. All right, this is a chunk of silicon. So it's kind of a glassy element if you look, and that's the high school physics version of it, of silicon. So there's a nucleus with electrons floating around. You want to click one, and what silicon has this interesting property, and a couple other different elements have this too. There's an animation going.
Oh, okay, sorry. Right here on the silicon.
There you go.
Oh.
So you can go back and forth, but That's basically what happens. You have an atom of silicon, it's got electrons on the outer shell. It's just a property of that element. A photon of light comes in, knocks that electron loose, so it energizes that electron, jumps to like the next level, and now is wants to move. And then it moves down the wire. Okay, next slide. And so here's our solar panel. We have a thin wafer of silicon. And in the old days, they would actually put it in an oven and they would diffuse phosphorus in the top and they would diffuse a boron atom in the bottom, basically adding, subtracting electrons. You put some wires on the top and the bottom, next slide. And now you stick this thing out in the sun, next slide. And we have photons raining down on our cell, energizing electrons. Because of this doping, it's called, with phosphorus and boron, the free electrons want to float up, they hit a wire, they're energized, they do something useful, they get tired, they come back in, another photon hits them, and that's how it works. This is just like a generator, but a generator uses a magnetic field to push electrons. Here we're using photons. Next one. All right, there are many different kinds of solar panels. This is called a half cell monocrystalline. So monocrystalline is the most popular. That's where it's a single crystal of silicon. It's actually kind of interesting. They grow these, they have this molten vat of silicon, and they put a little crystal in, they pull it up slowly, and it makes a giant tube of silicon, and they slice it. So monocrystalline is the most is the best. It's got the highest efficiency of turning sunlight into electricity. There's also polycrystalline, which is more. It's not a single crystalline. It's many large crystals. And then there's amorphous silicon, and you can package amorphous silicon in flexible sheets. That's what this is. This is what's on our freight house. This was for standing metal seam roofs, and this was actually like a sticker that you would peel off and stick on a metal roof. Not as efficient, but was cheaper to install. The mono and polycrystalline panels, they come in basically two sizes, a 60 cell version and a 72 cell version. And now what they're doing is they're taking these cells and they're cutting them in half, and they're basically making two solar panels on one panel, and this improves your efficiencies more. Tesla has their cells, their solar panels. They're fantastic. They look great. They're really expensive. And what people don't realize is they only plop down solar cells on a square on the roof, and then all the rest of them around them are just dummy cells to fill in the holes. So people think that whole thing is a solar panel, but it's not. There's just a couple of blocks of solar panels, and the rest are just fillers to make it look nice. We used to have a company called Unisolar up in Auburn Hills, and they made this product. They're out of business 10, 15 years ago. But it was kind of cool. This worked. They made a 3-tab solar shingle, and you would roof your house, but for every shingle, you had to drill a little 1/8-inch hole and fish a pair of wires down. And it looked great. It was a fantastic product, except until you went in your attic and you had 400 pairs of wires wired together. So I think that's what it's built out. Power panel was made by Dow. They're out of business now too. Catching the theme here. And they fixed that problem by making edge connectors, so you would nail down one shingle, and then you would electrically connect two of them side by side, nail it down. Then they had these jumpers that would go across, but it didn't take off. Next slide. So there's options. That's the main point. There's lots of options. Welcome. Coffee and donuts are over there.
Then I got a few more kids in case you need.
All right. It's crowd coming. And if anybody has questions along the way, there's a chair here. Just yell them out or chat them out. This is a complicated slide. I don't want to explain it, but I just want you to show that everything is getting up and to the right. Everything is getting better. The different as time is going on, like I said at the beginning, the first panel I put on was only 16 years ago, was 190 watts. Now that same shape is giving me over 400, 415 watts. So every year, the scientists tweak the chemistry and they can get a little bit more out of it, or they do this split cell thing, and it just keeps getting better and better every year. And one thing I've learned is, they're stealing technology from the computer business and putting it into the solar business. So we used to just put a wafer in an oven and just kind of randomly diffuse atoms into the top. Now they have what's called an ion writer, and they actually write atoms with a laser or something. So it's amazing. So it keeps getting better. This red stuff is these monocrystalline panels. The green stuff is the amorphous, and then there's all kinds of exotic organic technologies that are coming up. And you can also stack solar cells. All right, keep going. Next one. Oh, I'm sorry. Let's see.
I got
Say here.
Correct. So you were mentioning that the solar produce goes to the inverter and 100 pieces of breaker panels. So you choose specific breakers that your energy is fed directly to. Is that right?
You install a breaker. And typically what you do is your breaker panel has utility power coming in from the top, and there's that main off switch. Typically what you do is you'll install your solar at the bottom. So if you don't know anything about breaker panels, there's 2 bus bars in there. And those bus bars don't care where they get electricity from. So those bus bars are electrically connected to the utility at the top and connected to the solar at the bottom. I'll go a little more detail on a couple spots. So we know where the sun is now. We know about solar panels. We're making some power. And now what do we do with it? Right, so this is our inverter. Next one. 2 more slides. There you go. There are many companies selling inverters. Typically, if you go with a contractor will have one that they prefer. The one that I've been using the most now is called Solar Edge. It seems to be very reasonably priced, and what I like is it has a monitoring program, so you can actually see how much power each individual panel is producing. So it's really nice from a monitoring perspective. So Solar Edge. I'm getting a little off that. Let's keep going. So not time for that. So there's basically 3 types of inverters. This is called a string inverter, which means all the panels are wired at the top. All that DC power goes to that box, and that box does the optimization and the conversion in that one box. The opposite side of that is called a microinverter. That's what this is. This is made by Enphase, and I've used these quite a bit. So Enphase, we put this underneath the panel, and so there's no centralized box. So this box sits underneath each panel and converts the DC to AC, does the optimization and everything, and you have 240-volt AC power coming out.
Each panel?
Each panel, so it converts each panel right on the roof.
Make it expensive. Is it more expensive? It sounds more.
This is a little more expensive. Because you're not kind of getting economics of scale, right? So there you got one box, here you have multiple boxes, and also this has a little more installation cost because you're messing with more stuff up on the roof. But this is the one I prefer. This is called Solar Edge, and this is kind of a mixed mode. So you have what's called an optimizer. So this optimizer sits behind the panel up on the roof, and this does the optimization. So you got to realize that the sun is moving all over the place, right? And this panel is getting different amounts of energy throughout the day. And so what this does is this is changing that power. So you have watts and volts times amps. This is tweaking how it's delivering the power to optimize it. So you want to have this kind of converting the power one way the very early morning, and you want to do it another way when the sun is really deep down and you get out. So this is called an optimizer. So Solar Edge does an optimization on the panels, and it's still feeding DC to a centralized box, which then does all of the conversion at one time. And these are originally priced. This is probably the cheapest. This is what I use most of. And the other thing about this is, if you have a string inverter, and you have this, so typically this would be like 2 strings. So I would wire these in series, and that would go to the to an inverter, and I would wire these in series, go to an inverter. If I have a tree with a string inverter. I have a string inverter, I have a tree, and I shade this panel. This shaded panel could affect the whole string. Because it's treating this whole string as one thing. If I have optimizers or microinverters, if I shade this panel, I affect that panel, but I don't affect anybody else. So that's why I really like optimizers and microinverters. All right. These boxes, so this is very simple. I mean, this is it's two outputs. I mean, you have a positive and a negative going in, and you have two hot wires coming out. So it's a complicated box, but it's easy to install. That's the point. Next one. So this is what it looks like. This is at the co-op, or was at the co-op. We put our solar breaker at the bottom. DTE comes in from the top, and our solar power comes in here and just feeds the bottom of the breaker. Next slide. All right, here's the fun stuff. I got panels on my roof. They're facing south. It's 4 a.m. Oh, there's no sun. Hit one advance. And for whatever reason, I woke up at 4 a.m. and I'm making toast, dishes, margaritas, cookies, and hamburgers. and electrocuting myself in the breaker. So at 4 a.m., I have all of those appliances running. And there's no sun. This is solar power. So this is off. And so all of this electrical load is being fed by DT. My meter is spinning forward and quick. All right, next slide. Now it's 8 a.m. The sun has just risen a little bit. There's enough photons hitting my panels. I'm getting a lot of scattering and reflection because I'm at a really crappy angle. In fact, I didn't appreciate this until I started doing solar is the sun doesn't actually rise in the east in the summertime, it actually rises way over here. So even with the sun behind the panel, this will wake up. A little trickle of power, of DC power will come into the inverter. The inverter will wake up. It then listens to the power that's coming from utility and says, okay, this is what I need to make. And then it'll convert and I'll get a little trickle of AC power into my breaker panel. Again, the appliances don't care. I have a breaker at the bottom with my solar. I have DTE coming in from the top. And so now maybe at 8 a.m. I have enough electricity to power my toaster, but everything else is powered by DTE. So my meter's still spinning forward, but it's spinning slower. Next slide. So now the sun is rising, and as it gets higher and higher in the sky, I'm making more and more power, so I get more power coming in. I have maybe enough power for 4 of my appliances, but I still don't have enough. So I'm just buying a little trickle of power now from the power company. I need to mention this is called grid tie. We're going to talk about batteries a little bit later, but there's no batteries. This is called a grid tie system. All right, next.
And
so
we might lose power. I just want to announce to the people that are online, we might lose power on this laptop that we're running from because ironically, we don't have a power source. So if the webinar ends, give us just like a minute and we'll rejoin. We'll start it from another computer. So I just want to let people.
So they don't get kicked off. They'll all have to rejoin.
You'll all get kicked off, but you can rejoin. So if we get through the presentation before the power goes out, that'll probably be better, but we'll make it work.
We're close.
Yep.
All right, at 1 o'clock, this happens at the library probably every day now. The sun is perpendicular or at the optimal angle. I'm making a ton of power. I have all that power coming in. All of my appliances are satisfied. And I have an extra handful of electricity that comes in and it's got no place to go because everybody's happy. Electricity wants to go to the closest ground. And so what it's going to do is, animation's not working. Is that extra power will now flow backwards through your meter. And if you had one of those old-fashioned platter meters, they would actually slow down, stop, and it would actually start spinning backwards. The newer digital ones, it has 2 registers and it counts what comes in and what comes out. Next slide.
Oh, there it is. Okay.
All right, next slide. So where does that power go? This is our neighborhood. Here's a power plant down in Monroe. That's 30 miles away. Click. And there's somebody here shoveling coal and making electricity, and they're supplying electricity to all the neighborhoods. Click, and now you have 2 people here who went solar. It's a beautiful day, they're overproducing, and so power goes out of their houses their meters are spinning backwards, they're getting credit from the utility company. And they're sending power to this person. This person hates solar, but they don't know. They're just buying electrons. And they don't care where the electron comes from. So we generate excess power, we sell it to the utility company turns around and sells it to the neighbor. And we give them free delivery. So this is what really, when power companies really complain about solar and stuff, I mean, we're actually doing them a favor because one, we generate power, solar generates power when they need it the most on a hot sunny day when everybody's got their air conditioning going. And we're also giving free delivery instead of powering this house 30 miles away from Monroe burning coal, we're getting free delivery. So that's the goal. If we get solar panels here and solar panels here and some solar panels here, then we could ramp this down during the daytime at least, and maybe sell power to Ohio. Next slide. Next.
There we go.
Okay. This is just another way to look at it. This was when I had some monitoring program at the co-op. The store is closed. It's midnight. Here's a refrigerator coming on and off, compressors. The sun technically rised at 5:57. I'm 10 minutes later, I'm making power. This is power when the sun is behind the panels. Now the sun is risen enough that it's in front of the panels. And then here's a nice parabolic curve of solar generation, right? It grows during the day. Here's my local noon where the sun's directly overhead. The jagged lines are clouds that are coming and going. The red line is what I'm buying from the utility company. So somebody came in, turned on something. Here's like a coffee pot that came on and turned off. And you can see as I make more power, I buy less power. And at this point, something got turned off, and now I had excess power. So now I'm exporting power until here, when then I ran out, then I had to start buying power again. Next slide. Next. How are we doing on power? 10%?
I'd have to minimize the slideshow, but I think I can switch to this one at any point. So, because I made it a co-host, so just keep going. We'll.
Here's the economics. So I looked this up last night. So according to one website, an average Michigan home uses 668 kilowatts of power per month. And the average price right now is 18 cents. This is getting more complicated now. Everybody got a letter right from the power company saying time of day.
Yeah.
And in fact, solar is an advantage for that now, because they're going to charge more in the afternoon. Actually, if you put solar on your west roof, you'll be making the power when the power is the most expensive. So actually now this makes west look better than south. Or you'd have to do the math, actually, you figure it all out. Anyways, I take my monthly average, I divide by 30. So on an average day, I need 22 kilowatts of power to be solar power. Here's a website where I got the 18 cents. Next slide. Yes, probably. And if you have the DTE and you want to know how much you burn on an average day, you look at this little bar chart, you add up these numbers, take the average of these numbers, and that's how much you burn on an average day. Next slide. So Michigan gets what's called 4 hours of peak sun. The sun's moving all over the place, but the National Renewable Energy Lab says that you can pretend in Michigan that it's right over your panel for 4 hours a day. I'll show you that in a minute. I'm going to assume some losses for some shading and some electrical losses. So if I need 22 kilowatt hours on an average day, I have 4 hours to capture that energy. I need 6.6 kilowatts of power of panels to be 100% solar power. And that represents about 16 panels at 410 watts. So think about an array that's 2 rows, kind of like this row here. 2 rows of 8. This is 2 rows of 6. So this is what it would look like on your row. So the question is, what does it cost? Oh, here's 2 more clicks. This is the National Renewable Energy Lab. We are the worst place for solar because we have Great Lakes. It gives us lots of clouds. But we're kind of that color, which means we have about 4 hours of peak sun. This is where they want to do solar. Okay, next slide. And this is a blow up of Michigan. But you can still, it's all in the range of about 4 hours per day throughout Michigan. Next slide. So what does it cost? If you just call up a contractor and say, just do it, it'll cost anywhere between $3 a watt to $3.50 a watt. I've seen it as low as $2 a watt, and I've seen it as high as $4.50 a watt. So I really encourage calling multiple contractors. I need 6,600 watts of power to be 100%. At $3, that's 19.8. There is a federal renewable energy tax credit in place right now, 30%. So you get 30% of that back from the feds. So you knock off $6,000. So your out-of-pocket cost after taxes is 13,800. If you got a higher price, you know it's going to be 16,000. So is this a good investment? Remember, we have 6.6 kilowatts on the roof. We have 4 hours of sun. This is what the value of that power is. So you're going to make about $4.78 a day on average, and you're going to make about $1,700 a year. So if it costs $13,800, it's going to take about 8 years to pay off, and if it costs $16,000, it's going to take about 9 years to pay off. Now, there's a lot of other stuff to apply to this economics. One is the value of money, right? So if you don't have the money, you have to borrow it, then you have to pay for the borrowing costs, and that changes this number. The other thing is, in this analysis, I'm assuming electricity stays at 18 cents for the next 8 or 9 years. It's not. So as the price of electricity goes up, this will actually get lower. And this is what's nice, actually, from kind of a retirement annuity perspective, is this changes you from a variable energy market to more of a fixed market, because you bought it and you're going to have that power. No matter what the utility company changes their price at, you've kind of locked in your cost for the next 30 years. And solar panels last, usually warranty for 25, they'll last 30. Actually, it's all solid state. There's no reason why they won't last pretty much forever. What basically happens, what I've read, is grit and sand and dirt will collect and kind of grind the glass a bit, frost it a little bit, so you don't get the same penetration. But it's all solid state. There's nothing to break. Next one. Oh, wait. Importantly, anybody from the city that's planning, we have the Grace Sweeney Solar Rebate Program. I have flyers up here, and we're going to give you $2,000 right off the top. So if you live in the city, your payback went to 7 or 8 years. So if you're in the city, do solar. If you're not in the city, do solar. Next slide. This is saying that the world is just getting better. So the cost of solar just keeps getting cheaper. The demand is just getting better or increasing. And the more the demand gets up, the more we have more players, and the economics of scale. So that brings down the price. This is the cost of electricity. It's at 4, 5, and 6 inflation rates. And so electricity is just going to get more expensive, and solar is just going to get cheaper. Next slide. And this is only fun analysis. I'm in the computer business, and back in 1990, this is kind of my motivation. 1990, I bought this piece of junk for $2,000. It's got 50 megabytes of memory, 50 megahertz, a clock, and then in 2013, I bought this phone for $200. Basically, after 23 years, it got 10 times cheaper and saved 50 times better. And that's how I look at solar panels, right? So I did my first one in 2005, $1,000, 190 watts. Now I'm at $200, 450 watts. So I'm just trying to, I just want people to buy panels. I don't care, but the more people we create this demand, the cheaper they're going to get, and then it's just ubiquitous. I can't believe I bought that for $2,000. I'm almost done. This is a wonderful slide. It's complicated, but it comes from Lawrence Livermore National Lab. This is the United States, and this is all the energy that comes in the United States: oil, biomass, coal, natural gas. This is all of the way it's consumed: transportation, industrial. Oh yeah, you should put his presentation on if you want.
Yeah.
All the ways we use it. I'd like to look at this one first. Here's petroleum, oil. here's a bunch of oil that goes off the industry, the power industry, but I believe a lot of this is also plastics and fertilizers, things like that. Here's all of our cars, airplanes, buses. Of all the energy that comes in to our transportation, let's say 20% actually moves you down the road and 80% is lost. So when you're driving your car and you step on the brake, you're throwing away gasoline. You know, every time you hear that engine running, you're making noise, which is loss. You know, so it's amazing when you put that gallon of gas in your car, only 1 quart is moving you down the road and 3 quarts you're throwing away. So this is just the inefficiency. You know, you've got this engine that's blowing hot, right? That's just all losses. So it's amazing how much energy loss there is in our transportation industry.
Hey, Dave, we have a question from the last slide. Do
Okay.
you want it now or do you want to
Yeah.
wait on that? The person asked about, they said none of your math accounts for roof replacements and warranties. Any comments or observations on that?
Don't put solar on an old roof. You can, but well, if you have to replace your roof, or if your roof is, I would say, 20 years old. Well, actually, you have to look at the condition of the roof. But yeah, you should not put it on an old roof. If you do need to do a roof replacement, some people have been claiming the roof replacement as part of the solar project, because you wouldn't have replaced your roof unless but you are, because you're doing solar. So they're collecting some portion of that 30% tax credit on your roof. And some people will claim just the square of roof underneath their panels. Some people will claim the whole project. So that's up to your tax accountant. But you could kind of apply you could make an argument that the solar project is helping you, or is. Then you boil a kettle of water, and it makes steam, the steam turns these blades, the blades turn some magnets, and that's what pushes it down. So of all the energy that came into my electrical generation plant, 2/3 of it is lost, and 1/3 is actually delivered to your house. And we lose something on the order of like 8% just in the transmission. So another reason for solar, if I put solar on my house, I have 0 transmission loss, right? So I'm going to make power, move it 20 feet and use it. Even if it goes to my neighbor house, when I say I push the power out of my house, it's gonna go 50 feet, 100 feet, it's gonna go to my neighbor's house, which isn't that far away.
There was another question, Dave. I've switched computers now, so we're
You
on,
are like seamless.
we're on PDF now instead of PowerPoints, no more animations, but
Okay.
somebody said,
Sound just went out.
yeah, no, I think we're good now though, but there was a question. Let me just go to it. Yeah, what did they say?
Batteries, okay, that was a good time for batteries.
They said, your diagrams did not include batteries. Do you recommend?
Right.
them?
So I have DC power coming off my roof, and I have a battery. Batteries are DC. So if I want, and first I want to say, I want to decouple renewable energies from uninterruptible energy. So those are kind of 2 different problems we're solving. So I said everything is grid tied, and it's grid tied in the sense that if the grid goes down, that inverter does not see a signal, it will not turn on. And the reason is that, and it's designed that way because we don't want to be feeding electricity to a dead grid, because then the line person will be, grabbing the house wire to hook it back up, and he's going to be shocked. So the grid tied inverters will not work when the grid is down. then the way around that is either get a generator or batteries. Now, a battery bank for a typical house using lead acid batteries is like a coffee table. It's quite big. It's lead acid batteries. Lead acid batteries are about 100 pounds, 70 pounds a piece. And you need multiple of them. They need to be in a conditioned airspace. They could vent hydrogen. And then the other thing is that all of my DC power is going to go into the battery. And it's going to change it from electrical to chemical. So I'm going to lose some energy. And then I'm going to pull it out. And I'm going to go from chemical back to electrical. And I'm going to lose some energy. So
Your inverter loses energy though, too, on the conversion.
that is like 98. Yeah, there is losses, but that's like 98% efficient. I'm just saying, if you want to go batteries, it's going to add costs. From what I've read, they last about, I'm talking lead acid, 7 to 10 years. So out of the 30-year lifespan, you might have to replace that battery bank once or twice. And it lowers your efficiency. So it's, and for if you want a whole house thing, it's a sizable battery bank. Now you could go with a Tesla Powerwall, which is lithium-ion batteries, and those are much better, last longer, but they're also much more expensive. So I'm like, I'm great time. I don't have a battery. The power goes out. It usually goes out for a couple hours, and I just look. I'm actually recommending generators. If you want to ride out a day or two, I would get a generator. It'd be much more cost effective. It's loud. It's not green, but it seems like the more solution. I did have one person here. I just installed the solar panels.
There's no variation of having a switch and going from a backup battery when you need it. Like if the power goes out, you just hit a switch and it just feeds into the backup battery.
Well, a battery is a power source. So the first thing is you need to have it charged.
Right.
So you have to have a charge controller, which is another box. Yeah, you could have a battery, and
You can't do both.
I don't understand by default.
Feeding back into the grid and have.
You will, no, the battery, you can still have grid type and battery. So the power will go into the battery, power the house, and then if there's still any excess, it will feed back the grid.
Okay, so then
That's the standard setup.
so if there's a loss of power and you still have power in the house, you can feed off the battery.
Then you use it off the battery. Right. And the other thing with batteries is you kind of have to decide what's your worst case. You know, do you want, because the battery is called amp hours, and do you want to ride out for 4 hours? Your battery's this big. You want to ride out for a day? It's this big. You know, you want to ride out for a week? It's huge. And I was saying, I was doing an install. I finished an install, and the guy said, you know, so will you put batteries on this? I was like, well, you know, for how long? And he's like, well, what if I wanted to go for like a month of no power? And I said, a month of no power, you got bigger problems. Because I said, you know, even then, I think I would get an LP tank and a generator. I don't know.
Can you run big loads like dryers and washers?
It's got a size in your battery bank.
Right.
Right. So that's usually what I would recommend. If you want to go batteries, I would make a smaller battery bank and just power your fridge and your heater and your air conditioner, stuff like that, your critical loads.
Will the battery continue to charge when the power grid is down? If the sun is
Yes.
out? Okay,
Yeah.
so it is a workaround from being like grid tied kind of,
Batteries give you uninterruptible power,
yeah, okay.
but they cost, lower your efficiency, and they don't last long.
But practically your grid is down when it's a storm or when there's no sun out. You know, it's
I don't-
Well, the
cloudy.
next day it's usually sunny.
Yeah,
I
I've
get
experienced a
so-
lot of power outages on sun.
I will say there is one inverter, that red one actually, Sunny Boy, that makes a separate circuit. So they have like this emergency circuit. It's just like one outlet, such that if the grid is down, it will disconnect from the grid. But if the sun is out, it will, and there's enough sun, it will supply electricity to an outlet. Or maybe your laptop and a fridge, or something like that. But it only works when the sun's out. Where's the ideal for this system?
It depends on the map.
Depends on the battery, lithium or lead acid.
Okay, and when you talk about lithium, is there any more efficiency in that type of battery?
So lithium is a way better. They're just more expensive.
Yeah, if you talk about power losses with the chemical battery. Versus.
No, I don't know, that's a good question, I don't know about the sufficiency of a lead acid versus.
When he talks about the efficiency loss, when you have to convert it from solar to the amount of power to feed the battery, it doesn't matter what that battery is, the efficiency loss is still there. The efficiency loss is mitigated by how good your charge controller is. The charge controller doesn't care what the battery is.
And on that too, lithium ion technology is changing, lithium phosphate batteries are entering the market now, they're a little bit more efficient as well, so we're continuing to see that technology change.
Yeah, I don't wanna. I'm not a battery hater. I just don't think it's economically viable personally today. I mean, batteries are getting tremendously valuable. And actually, what I think is gonna happen is, a couple of years down the road, there's gonna be a lot of electric car batteries that are gonna be on the market.
Right.
And that battery is designed to be light, it's gotta go in a car. And then, you know, you want a certain efficiency, but if I'm just parking it next to a house, I don't care, but I could stack them up. So I think somebody's gonna be converting car batteries into house batteries. I just don't think it's there today, that's what I'm,
Gonna go
All right.
next.
next. I can't believe you swapped like that, so,
I went to the Solar Ypsi website.
ah,
I
you did.
didn't think I should hack into your email, so I didn't send myself your email presentation.
This is funny, because I updated this one last night.
Good.
No, so this is the old version.
Oh, okay.
That's fine, that's not.
Yeah.
Anyways, it says the same message. About 30% of our CO2 emissions comes from making electricity. So that's a good reason for climate change. Next one. And that's it. Solar Ypsi, we have a website. Actually, yeah, can you just go to the website now?
Yeah.
And hit the installation page?
Yeah, let me start a new share.
And have you downloaded the absolutes?
Not on my computer.
Yeah, or if you want
Or I
to
can
give me
send
on
it to
a
you right
flash
now.
drive, yeah.
You should send it to her because
It's
we're
already
all
connected.
connected with all this other stuff. So this is what I've been trying to do with Solar Ypsi. I'm trying to make it easy for people to understand how to go solar. So we have over 100 different installations. Here's the addresses or the name of the school. You know, some are in Detroit, some are in Ann Arbor, some are in Ypsi. This is when they were installed. This is the type of panels, the type of inverter. So you can see Solar Edge is kind of the most popular. And this is kind of the most important. You can click on the top here and sort by installer. So if you're going to go with a particular installer, you can look at the different installations. And then I have pictures. This is the number of pictures I have for each installation. So you can kind of get an idea of what their work looks like. And some I have videos. And that's it. We forgot to talk. So I'm done. Why don't you go ahead and get him set up.
Yep,
You're gonna take off. All right.
thank
Thank
you.
I've got a quick question on the flexible roll bar.
Yeah.
That's still produced?
Yeah.
No.
Well, this one isn't. There are other flexible, it's called amorphous solar. Manufacturers out there, I haven't researched it at all, but I know they're awesome.
You said that was less efficient than the panels. How much less efficient?
Yeah, so my numbers are old, but a typical monocrystalline would be like in the order of 22-23% efficient. This is like 8. Or it was like 8, I don't know what it is now.
They get up to 12, but that's still fully out.
Yeah.
Right, and then.
But the advantage was I didn't buy any rack.
So from a cost standpoint, could you install enough of the flexible material, like amorphous material, the same cost to make up for the generation?
Yeah, because it was quite cheap.
If you stay on order of magnitude half the cost of the panels.
Don't remember, because when I bought them when they went bankrupt, I bought them at the bankruptcy. So I got it for, I don't know, 40 cents a watt. Yeah.
I came in a little late, would you introduce yourself again?
So I'm Dave Strenski. I'm from Solar Ypsi. We're a this is Kurt's there. we're a loose group of volunteers that have been helping people in the area go solar since 2005. And we've done some volunteer projects. So like the city's fire department has 227 panels on it. The fire department is basically 100% solar powered, which is kind of cool. We instigated the project on this roof that I need to talk about. So on this roof here, there are 106 panels. This presentation is solar powered. And I don't know if we did the math yet, but are you like 25%, 30%?
I think so far, I mean, I think our first summer here is gonna be a really cool
Well, that's right.
way to
haven't done a
see it.
summer.
We opened in November, so we've only been running the solar on the kind of worst part of the year.
Yeah.
So, but still, it's quite a bit. On the digital display out in the, in front of the checkout desk, you can see one of the slides that comes through will show what
How much
the.
dollars coming off the book?
We are dying.
Yeah, so there's 106 panels on here. Freaking, it's, I forget the water. And then, the other library, downtown Michigan, same side. 12 panels. 50 something, that's right, we did a volunteer project at the city pool, and that roof was more or less filled with 50 some panels. Now, I'll go ahead and do a little more here is,
Oh, another question, Dave, is that okay?
Yeah.
Do you ever have to clean the surface of the panel?
good question. Because I had a friend who wanted to buy a snow rake just for that. So, let's talk about snow first. I had a friend who said, I'm gonna buy this $20 snow rake and I'm gonna sweep the snow off my panel. And I said, terrific, but you're probably wasting your money. Because when the panels warm up, it's an aluminum frame, it's a dark surface. Once one corner gets exposed, then that cell starts making power and actually starts to warm up the whole panel. And so it doesn't take very long after the storm for the snow to slide off. And in the wintertime, the sun is at the worst angle. You got the most clouds. That $4 and whatever I was making a day. In the wintertime, I might be making $1. And so if I spend $20 on a snow rake to scrape it off, I mean, I have to have uncovered my panels 20 times before that rake pays for it. So that's just kind of an idea.
And what about like dust
Yeah,
and grime?
okay, again, if I had a ground mount system where I could just kind of walk up to it and wipe them, I would do that. I would never climb up on a roof to wash them because it's not worth it, because the rain and the snow will clean the panels by themselves. In fact, I actually got an email from some company who's claiming to do solar panel washing. And I said, nope. I said, it's a waste because it was gonna be like $50. And I was, what am I gonna gain? You know, I gained a couple extra bucks every year. So it wasn't worth it.
We've got that
All right, let me just
presentation.
do one more, this is my, show and tell. So this is what it looks like. We have an asphalt shingle roof. This is called a piece of flashing. They come in many different versions. You peel up the shingles a little bit and slide that underneath the shingles. And so they give you so it's underneath the shingles, so it's like flashing. And then you line this up so it's underneath one of your roof racks. And then you put a lag bolt. And so you have a 6-inch lag bolt holding this to your roof. And then this is a watertight. Maybe not this one, but I'm using 15 inch. This is a watertight connection, and then this bolts on there. You have what's called an L bracket, right? And then you have a rail. There's many different versions of rails. And then your solar panels sit up on top of it. So your panels actually sit, 6 inches off the roof. Now I want to get back to that question about the roof. Once you put the solar panels up, the roof underneath the solar panels will last forever. Because they're not getting hit with any elements, right? The sun's not gonna bake them. They're not getting hit with rain or anything else. So once the panels are up, the roof underneath is gonna be great. But it's not, but I wouldn't put it up on an old roof.
Like it might void my roof warranty.
No, it depends. I've taught neighborhood roofing how to do solar. And so they'll replace your roof and put solar up at the same time. And they'll warranty it.
Did you just mention a company? Neighborhood roofing will replace the roof and put up the mounts at the same time?
Yeah.
Thank you.
But most companies will do that. In fact,
Others, that's what I was gonna get.
well, I think any solar contractor would subcontract out a roofer to do all of this.
I think the roofer here did that.
And then you wanna add solar,
That's what I'm thinking.
yeah, that's what I,
Yeah, I wouldn't worry. I mean, this is an engineered, listed product. It's a piece of flashing. Yes, you're making 20 or 30 holes in your roof.
they don't leak, you usually never.
This is a heatable room, picture your shingles. So any water up here is gonna go over your shingles and then land on here. And you drill a hole, a pilot hole, you put a gobble caulk on it or sealant. And then you have this lag bolt that ties it down, and then this is engineered, you can't see it, but the aluminum actually extruded to come up. There's different versions, but. At least it's like. I'm gonna write down me. Right, and in fact, I've missed the rack. So I drilled a hole, I measured out, and you can tell I missed the rack. And I moved over 2 inches and I drilled another hole and hit the rack, so I have a hole in my roof. I put some sealant in it, but it doesn't matter because all of those holes are underneath this piece of flashing. So I have no recognition.
Concern about like added weight, like how much do they?
So a solar installation is equivalent to about a quart of shingles. So a lot of times the roofs are designed to have actually 3 layers of shingles, lazy roofers. Yeah, so it's not a tremendous amount of weight. Although if you're in the city, or even in the township, our building department gets a little, that's the biggest sticking point. Is Ypsi has a lot of old houses, and so I put solar on houses with 2x4 rafters, like a garage. Actually, that was the worst one. This house, this garage was so old that they weren't evenly spaced, they were randomly spaced, and they weren't even parallel. It was crazy, and it was 2x4s. So the city made us put in a couple more joists in the attic to make sure that the roof was stiff enough to hold the thing. But in general, it's not an issue. If you have a metal roof, people with standing seam metal roofs, we make a product like this. It's called an F5 connector, and this clamps right onto the seam. And so there's no rails, and then your panel sits inside there. So if you like metal roofs, that's the way to go.
So do you have to get a permit from the city?
Oh, yeah, you have to, you can do it yourself. I mean, I've done several DIY projects, but you have to pull a building permit and electrical permit, and then you also have to go to DTE and pull a cogeneration permit. Because DTE has to approve your project before you start.
What if you don't plan on using grid tie? You need to tell about the DT.
You don't have to tell DTE if you don't permit it. And even if you are group guy, I have one person who, this is interesting, he hated DTE. He got Enphase. Now we have these smart utility meters. And they'll measure power coming into your house. And if you put solar on your house and you didn't do anything, didn't tell DTE anything, and you started pushing excess power out of your house without telling DTE, they would be charging. They wouldn't know if that's in power or out power. So they would think that it's in power, and they would be charging you for everything you send out. So that's how they prevent people from doing kind of rogue solar. But Enphase has an option on their inverter that says never export. So he put panels on his house, and when the sun is out and he makes it and he consumes it, but the inverter will never let it export, so he never gets charged for DTE.
When you select that option, what does it do with overproduction?
Goes away. Doesn't. it
Do you
never
know what
happens.
heat? Is there a resistor? Do you know what it does?
It's like an open circuit.
Okay.
Yeah, so we're doing. All right. Cool. So I was putting together this talk. This was actually scheduled before I met these guys, but then I met these guys and they're like, come on in and Also,
Talk about it. People.
Yeah.
So I'm Pete, by the way, very nice to meet you, so glad you're here. We are always extremely interested when we have people that are interested in solar, want to talk about it. So we are representatives from Absolute Solar. Here's our addresses if you have any questions, anything like that. I'm Pete, this is Adam. Fred is not here today, he had some family obligations. So what we're planning to do is, we won't take up much of your time. We want to give you a generalized kind of presentation of what a solarized event is. Most of what we would normally say has been covered much more in depth than we would on the Zoom or anything like that. And then we will stay here to answer as many questions as you have or want. We would be happy to get you with a free proposal if you would like that. So what we're just trying to do now is introduce the idea in a general way. So if people have obligations and they want to leave, go ahead. But if you want to get into the kind of nitty gritty in depth, Adam and I are here to do that. We will also always take emails or calls if you have to do it at a later date. I'm the guy that 15 minutes after the meeting is done, it's like, why did I not ask that question? So please just give us a call, email us. We are more than happy to speak with you.
Yeah, and if you got anybody on the Zoom, if they, I don't know if they can see me, I don't know where the camera's at, but.
They can see you, yep.
Okay, yeah, any questions, feel free and just let me know and we can talk about it. We got business cards as well. Before we leave, we'll get you guys, if you guys want quotes and stuff, we'll make sure we can get some of your information. We have QR codes you can like put in the information. And we just basically need your, name, number, address, and utility bills, obviously super important because that helps us understand how much energy you're using in the home. And we'll get into that too, but. Let's move on.
Yep. Oh, wait, I don't remember which laptop I'm on here. There we go.
Okay, so generally question, what are the benefits of solar? I can kind of move out of the way so everybody can see. Good for you, good for the planet. Payoff, a lot of times right around 10 years. And then once you have that, you paid it off, and it's all just money that is being made by your system through the utility. Panels have a warranty of 25 years. The ones that we propose actually have a 30-year power output warranty, which we really are happy to do that. Adds value to your home. If you're looking at apples to apples, I want a house. One has a very, very low electricity, electric bill. One has whatever the current rate is. There are lots of people out now that are looking for houses that already have panels on them. Some states are actually putting regulations where houses have to be solar ready. Michigan's not quite there yet, but right now that number of, we don't know, still young. It'll add somewhere between 4 and maybe even up to 20% of house value. When you add solar, there's no increase in property taxes, which is Governor Whitmer signed into law 2019, I believe. One of the things that Dave kind of mentioned, there's no maintenance involved. It's just the flow of electricity. You're a little bit, want to get snow off your panels and they're able to reach it with a broom or an extendable squeegee, something like that. That's fine. A little bit of dust, some leaves, some pollen, and maybe gather in the summer. A good rain's going to wash that off. We don't live in New Mexico where you're going to just get caked with dust and dirt. The way that we solarize works, and this is we're trying to form a group here, is what we will do is based on a lot of different factors that we will look into and talk to you about for your house, give you a price, but you are guaranteed 5% off the market rate. If one person in this room decides to go solar, you would get 5% off of whatever the market rate is. But if 6 of you went solar, then all 6 would get 6%, 7%, 8%, up to 15%. So it's designed to be an incentive as a group buy for a group that's close in location. And then, so you could get up to a 15% discount off of your solar. And then as mentioned earlier, there's also the federal tax credit. And then there's some other options in Ypsi and around. So that could factor into making this just a tremendous deal. Yes. A lot of people looking to financing. We do not finance ourselves, but we are preferred contractor through Michigan State, which is a clean energy consortium of credit unions and banks, good competitive rates, nothing hidden on the back end. Feel free to go through and we have some literature and it's always on our proposals. So look at rates, pay that. Hey, maybe you want to just offset what you're paying in electric right now. You can work that out with the lender. Basically, what we install, again, we're more than happy to have conversations about what you want for your roof. Usually we use Silfab panels, which are exclusively American made. It's a Canadian owned company. They are 370 watts, so a little bit lower of what Dave was talking about, but they are all black frames, really aesthetically nice. 20.2% efficiency is very nice. It's a tier 1 brand. You want to go up in efficiency, you're going to go up in cost. Is going to be the kind of the nuts and bolts of it. What we really like to do is find the best quality materials we can, but also get the right price point to make this as beneficial for you as we can. Industry leading 25 material warranty, 30-year power output guarantee. So that is, again, industry leading. We use Iron Ridge racking, which Dave had some of right there. And then generally we do N-phase microinverters if you want it, but our general go-to is Solar Edge optimizers. The main reason being they're a little bit more efficient and they're a little bit less expensive. Both are battery compatible, so if you want to have that conversation, then we can. And again, just going a little bit of pricing. Every house is different because every house uses a different amount of energy. Do you have kids? Do you have vacation during the year? Do you have heated floors? Do you have a heat pump? All of those things factor in. That's why that most important thing that we will ask for first. Dave showed you that DTE bill. Does anybody here not DTE? Didn't think so. That's fine, but then they give you that 12-month bar, and that tells us exactly what we can offset in a year. And so what we will do is we can use that graph and build an energy system for your house. And then, so basic system, again, we're 5 kilowatt hour size system. It's going to be somewhere around that, probably 350 a watt. A year ago, we were closer to that $3 a watt. Inflation has hit a lot of things in this world. Unfortunately, that's part of solar costs as well. But what you'll see is again 350 a watt at 5K system, about 17,000 and a half, 17,500. With that guaranteed 5%, that drops that down. When you take the 30% tax incentive you go in, it's an $11,000, $11,500 system, and the price per watt drops way down when you have those systems in time. So again, that's just a basic. A bigger system is going to be a lower price per watt, but that's again just a generalization of kind of what we're looking at. Next slide. The way the Solarize program works is it is on a timeline. So we would say for 1 week from today, although we're not going to be working next Saturday, I hope. But if you are interested in getting a quote from us within this program, let us know by next Monday. Send an email, make a phone call. We have a sign-up sheet that you can do today. Just let us know. Then at that point, we have 2 weeks to get a proposal to you. We will try and get it to you quicker than that, but that's the time frame that we have promised. If we have to work overtime to get you that proposal, we will get you that proposal within 2 weeks. Then you have 2 weeks after that to make a decision. You want to talk to some other companies, try and shop that, fine. Go ahead. They probably are not going to have the same incentives. We won't know exactly what the total group buy is until the end. But then by like April 17th, we would know you want to be in, you want to be out, and then later that week we can say, hey, your total discount is this. Here's what your benefits are. The last slide. Oh, and then just and if you're interested, we have a sign-up sheet. You have this QR code that you could send. A lot of us, it's going to be from email from us. You have the phone numbers where you can reach us with any questions. And then, like I said, we are going to be here for a little bit. We can talk about individual Well, if you have any questions right now, that's fine, but also if you think, have questions that would be individual to your house, your neighborhood, something like that, we're absolutely willing to stay and answer those questions.
What's the dimension?
Yeah, let's open it up for questions.
It's about
Anybody,
3 foot by 5 foot, give or take. Yeah, we can get the exact.
there's 40 inches by 66 or 60 cell panel, or
Mhm,
40 inches by 80 inches for 72 inch.
yeah.
72.
The steel
cell.
fab panels that we use for these quotes, yeah, it's around 3.5 by 5 per panel.
Google
And
some-
your guys is like electric bills, like as we talked about, that'll tell us how many
The libraries.
kilowatt hours you use in a year, and then that. We can, basically do the assumption of how much kilowatt size system you would need based off of that data. And then we can, maximize based on what DTE will allow for you guys to have, which is crazy to say that they limit you. But yeah, they'll tell you how much solar you can put on your house, and then we know at least what the maximum is, and you can always scale back from there. You don't always have to like do full offset if you want to, you have a budget in mind or something like that. That's what I did on my house, and I actually financed, part of my project too. I put a down payment towards it, and then the rest I financed, which was roughly around what I was spending on my electric bill anyway. So it kind of made it a simple solution there. But
Do my house.
is there any questions in the
323.
chat? Or?
No,
No.
Well,
This is
okay.
our potential here.
I just want to mention a couple other things. You could do your own rough estimate at home, right? So just get your power bill. You want to find that average per day, divide by 4. That's the size of the system you want. And it's going to be 3.5, something in that ballpark. So that gives you the ballpark number. And then for sizing it, like I said, panels are always 40 inches wide, and they're anywhere from 66 inches to 80 inches long. And so you can usually put them in portrait mode. And so you can go up and you can just look at your roof and see if, how many will fit. Sometimes we try to make the house 100%. Sometimes we try to make it whatever will fit on the roof. In fact, we're getting kind of dinged with the building department now because they've kind of instituted some new rules. And what's really hurting low-income houses is they want a 3-foot strip on this edge, a 3-foot strip on this edge, and a 3-foot strip on this edge for firefighters. They want roof access, so in case the house is on fire, they want to pop a hole in it. Which is not bad on a typical middle-income house because it's a bigger roof. But if you have a 1,000-foot or a 1,500 square foot house, particularly if you have like a gable or something, then it can really hurt you.
And just to piggyback off that too, is something that we do is, we do all the permitting, we do all of the electrical connections. You don't have to worry, you don't have to lift a finger. And as far as like building heat sinks, what to do, you guys don't have.
Right, that's what's nice about going with a contract.
Yeah,
They
they
do
do
it
all the permitting for it. We know what the setbacks are based off of the roof, and kind of like what they're showing you on the screen here. We can do an analysis based on the value of protection. We know what the dimensions of your roof is. And we can factor in how many panels can fit on there with actually not even having to go out to the house and measure it in every single facet, which is great.
And you can do this yourself. So this is the free program. This is called Google Project Sunroof. And you go there and you type in your address and message.
Oops, sorry. Perfect.
And you want a roof that looks like this. So that the brighter the brighter the roof. So this is actually, it's amazing stuff. This is LiDAR technology satellites, and they're able to scan every roof and do this kind of analysis. And so you can see this guy's, it's got some shading. You can see here's a tree, south is down, so this is a tree. So you can see this is all where you don't want to put panels. On this roof, I think I would put them on this this garage over here. So this is very useful to just get a first pass analysis of your house. Type in your address here, and it'll tell you whether. I had the previous mayor wanted to really go solar. I looked at her house and it was bad. It was like, I was like, you got a lot of great trees.
I just did the downtown library.
There we go. This is downtown library. So any kind of a flat roof, there's no trees, no shading. Higher is always better. So if you have like a 2-story barn and a ranch, put them on your barn because higher gives you a better solar window from the top. So we have solar panels right here on the downtown library.
And City Hall.
Actually, on this roof here, this roof is filled with panels. And you can do a couple different things. You can do on the roof, you could do ground mounts. So I've done ground mounts in backyards, and they put like a little garden underneath it, which is kind of neat. And And I've done awnings. Where you kind of cantilever them on the south side of a house, and it's kind of nice because we did it at Park Ridge Center and it made shade for the windows, so it lowered their heat load on the house.
Hey, Dave.
How does that work with like if you have a ground mount, or if you have like a separate, like an external, or like a detached garage, like how is that tied in?
As long as, if you have power in your garage, you're good, because you could just tie into the garage.
Mm.
If you don't, then you just dig a trench. In fact, I did a ground mount, 1 Oak Street. You want to pull up? Google
Yeah, I'll
Maps?
pull up Oak Street and then, this person wants to know, how can we tell if our house is too shaded?
Where's
Is
the
there
Google Sunroofs?
Target, yeah, so look on this site,
Well,
target
Or,
number.
or call a contractor, because the contractors
do this for them.
will do this for you.
So they can get and find the best spots that it can go.
Yeah.
Mhm.
As well.
So I had one, if we drive past 1 Oakwood in Ypsi,
Yeah,
their roof was terrible, but they had kind of a nice big backyard and they had a fence along the north side of the property, so we built a ground mount array that was parallel to the fence. So it kind of blended in with the fence and then trenched it and hooked it up to the house. So I was surprised to see, let us do a ground mount in a backyard in the city.
Yeah, it depends on where you're at. If you live in the city, a lot of times ground mounts out, just because of the setbacks between like.
Setbacks and aesthetics.
Aesthetics is a big one, and trees obviously probably more important, especially if you're in the
I wanted
city.
to see if I could find a satellite view of it.
That's something we can determine, yeah.
Yeah, I'm
Look at the different mountings that we had there, we had a mounting for like a rig metal roof, right? Yeah, I have a shingle metal roof. Are you aware of mounts? for that?
You probably told me something. Well, there are dozens of different messenger companies out there that are all selling different products. There are products to put them on tiles, Spanish tile roofs, and there are tricky things that will hook underneath a shingle up above. So yeah, I'm sure there's a product that will, that's right, yeah.
So my roof is about halfway through its lifespan. Should I just put solar on it, or should I re-roof it first?
So are the edges curling on your shingles?
No,
Then I would just go with it.
Yeah, if you had at least 5 to 10 years without any roof and why go in, it's always depending on the manufacturer of the roof shingle. Some of them are gonna last 10 years, some of them are gonna last 40, it really depends on how well it's constructed and just the material itself. But if it's at the last half of its life, you're saying, if it had at least 10 years, that's usually when your solar system would already be paid for. And in that amount of time, yeah, it costs more money, again, for you to have to do the re-roofing at that time, take solar off and put it back up. But you'd be saving that money on the solar side of things during that entire 10 years, as opposed to waiting for whatever the utility rate is in 10 years.
So the shingles under the panels should be good forever. And if you had to re-roof the rest of the house, you could re-roof up until, at the edges of your panels. And around, or you can take it off. I mean, it's not terrible. I've done it. To take the panels off, re-roof and put them back on.
And that's
Because a lot of the work is figuring out where those damn rafters are and doing all the conduit work. And so once that's all done, to kind of redo it is simple. Yeah.
so. I was talking to somebody, so I'm in the process of still electrifying,
Okay.
which means. Heat pump furnace, heat pump, hot water heater.
Yeah.
Electric stove. In the future, electric car. So as I get the panels. And you design it to that, but as I electrify,
You can grow in a couple different dimensions.
but do I need that? Is it easier to get that planned in advance? Or once my solar are up, 5 years down the road, have them replan it and redesign it or whatever?
We do a lot of that phase work for customers, because everyone's gonna be like, oh, in the next 10 years, I'm probably gonna have an EV, what's gonna happen now? So you can do some prep work on the front end, especially if you know what you're gonna get, if it's like in the next 6 months per year, you can plan that on the inverter side. Depending on the side of your system, inverters are limited with capacity, of course, but you can always size those things up on the front end with Enphase micros. You can just plug and play those pretty much until the end of time, there's limited, of course, but you can do things in phases and when you do that.
Let me expand on that. So one method is to So the inverter has a rating, a wattage. And so you can put in an extra large inverter, put in half the panels for it. But then you're over buying the inverter, and sometimes the inverter will not work the same. If I buy a big inverter, put 2 panels on it, then the inverter might take longer to wake up. It needs a minimum voltage before it'll start working.
You don't wanna go crazy.
You don't want to go crazy. A lot of, the best way I would do it is, I would do your house 100% on one system, and then do all your other stuff, find out what that electrical load is, and then you could add a whole nother system, and it's just another breaker, so there's nothing stopping you from putting 2 breakers in your breaker house. So this is solar system 1, this is solar system number 2.
And you can retrofit it so it's all in the same one system, you know, you can.
Yeah.
Retrofit it.
And I've done that too. I've done one where the inverter is there. We got some more grant money. We doubled it. So we actually took that inverter out and sold it on eBay, bought a bigger inverter and added more panels. There's a couple different options. Let's just put it out.
And honestly, most of it is tied to the utility. So they'll only allow you to
Yeah.
offset what you can do right now. So you can either add an EV, heat pump, you know, whatever that is, and see how much electric usage goes up, and then we add it up on later. Or they actually will allow you to submit with a receipt. Look, I know my electricity usage is gonna be increased. I'd like to add this many panels. That's an estimate. So, but yes, expansion always is an option.
Yeah.
Did she say that you all would handle that piece of ATE?
Yeah, it's the interconnection application.
Contractor will do all that work. No, you do nothing except write the check. Anyway, I had another thought. So I'm actually doing what you're doing in electrifying. So, but my panels are 12 years old or something like now. And I just added a heat pump hot water heater, and I'm gonna go with an induction stove. And so I'm gonna grow. My system is so old now, though, what I'm gonna do is I have 250 watt panels. So at some point in the next 2 or 3 years, I'm gonna swap out the whole system. And in that same footprint, I can double my power now, because everything's improved. So that's something else to think about, is this technology is just gonna keep getting better. So you might put in a system now, and instead of installing a second system, you might just swap it out for a bigger system. And let me also make a point here and not sell you on solar. So solar, what we've told you today is 8, 9, 10 years return on investment. What you really want to make sure, if you want to save money, cracks in your foundation or leakage. I read an article one time that said the typical house, if you add up all the little cracks, it's like a 3-foot hole. So a can of spray foam, go into your basement. I want everybody to do it. So everybody go in their basement, look at where the plate hits the foundation and where your floor joists are. Put your hand up there and see if it's cold. And if it's cold and there's a draft, get a can of spray foam and start sealing those cracks. And you'll get a return on investment of like 6 months. So sealing cracks is actually the most important thing you should do for your house. Insulation, if you put insulation in, you reduce your heating costs and your air conditioning costs. So you should. So I've actually talked to a couple of people out of solar and convinced them to do a home energy audit, which costs about $300 or $400. And then you'll have a professional come in and do what's called a blower door test. They do these infrared camera shots of your walls, and so what you can do is you can actually lower your overall electrical usage, and then your solar system is cheaper because now you're trying to cover a smaller load.
And there's a kickback from the IRA.
Yeah, you probably get that. Yeah, insulation, you can get that same tax credit on insulation and things like that. So solar is cool, and I want you to do it. But sometimes it's more beneficial from a money perspective to do insulation. It's not sexy, but insulation and sealing cracks.
So if you already have, say like batting up there in your rim joist, you recommend pulling all that out and resealing?
I can answer that one.
Can you?
I had a whole house audit and we looked at that. And we pulled down some of that batting, and it was just black because of the air leaks that have been coming through for years. So I took 2-inch foam, cut it to size, put it up there, then I spray foamed around it and hold it up there. And it made a huge difference. Just.
That's right. Well, we're almost like brothers, because I did the same thing. And my basement between the floor joists, and when it hit the foundation, I was messing around there one day, and there was a piece of fiberglass insulation there. But I had my hand up there, and there was a breeze. And it was just going right through that fiberglass.
Mm.
And so I systematically went through and took all those little, because they're little squares between the floor. I pulled them out, I took spray foam and I cut foam insulation, and I just glued them in, like 3 or 4 deep. And I just systematically went between each floor joist, and it made a big, huge difference. That's where most of the people don't realize, but where the plate sits on the concrete or the fieldstone foundation, that's usually the most aeration. And then that plate, the floor joists go like this, and then there's usually like a 2x6 or 2x8. And that's it. There's a 2x8 between you and the outside, maybe a piece of siding. And so that's the place a home energy audit will tell you that, or just use your hand.
And a big place too is the attic,
The attic.
we talk about insulation, but the other big part of that, especially with roof life, is ventilation. You want airflow in the attic, like in your soffits, you want to make sure there's gaps there for the airflow, because that'll make your roof last longer, which is obviously important for everyone, because those are not cheap, expensive either, so not only will it help energy costs, but.
Yeah, and nobody should have an incandescent light bulb in your house. Just throw those puppies out, and then throw out all your compact fluorescents, because LEDs are amazing now. And they have all the different styles, so that's simple. That's, changing light bulbs. Cracks, a can of spray foam can do wonders. Get a quote. Doesn't hurt to get some quotes and see what it costs to go solar.